Among the disadvantages of emulsion include creaming or breaking. Breaking is also referred to cracking, okay? And this can happen to an emulsion if it is not well formulated or wrongly stored. Storage of an emulsion is important, and if we store in an extreme temperature, as an example, too cold or too hot, the two phases may separate, okay? May get separated, and this will lead to either creaming or cracking. As emulsion is a liquid preparation, it is of course a bulky formulation. The unpleasant taste may still be there, okay, even though we add a flavoring agent, and the dose accuracy will depend on patient's measuring ability, and there is a possible microbial contamination. So for an emulsion that is planned to have a long storage, it is advisable for us to add a preservative. The identification of an emulsion can be done through 4 different tests: miscibility test, conductivity measurement, dye test, and staining test. So in the miscibility test, basically we will mix, or we will add or try to dilute the emulsion with either water or oil. So if it's a oil in water emulsion, it will be easily miscible with water, and if it is a water in oil emulsion, it will be easily miscible in oil. Conductivity measurement will be positive for oil in water emulsion because water can conduct electricity. The dye test will depend on the type of dye used. If a water-soluble dye is used, the coloring agent will be distributed throughout the oil in water emulsion, but it will remain as clusters or clumps in water in oil emulsion. Because the dye is water-soluble, it will be easily to be mixed with oil in water emulsion. The last test is the staining test. By using cobalt chloride impregnated on a filter paper, the paper will turn from blue to pink if it is exposed to oil in water emulsion. So the 4 tests can be conducted, but I think the easiest that we can do is the miscibility test. Emulsifying agents are a group of chemicals or ingredients that are needed in the formulation of an emulsion to ensure the stability of the formulation throughout its shelf life. It will help to hold the dispersed internal phase and prevent instability from happening during the shelf life of the product. So it is a very important agent, a very important ingredient that needs to be added in an emulsion. For an emulsifying agent to give its beneficial effect, it has to be a good agent that are not non-toxic, non-reactive. It means that it should not react with the other ingredients available in the formulation. It has a negligible taste because we don't want the agent to disturb the taste that is present in the emulsion. Will not change the pharmacokinetic of the drug. It means that the agents will not change anything or will not influence the absorption of the drug or the emulsion from the intestinal tract. It will not change the metabolism of the drug. It will not induce the metabolism of the drug. And also, the emulsifying agent has the ability to interact with both the aqueous and non-aqueous phase. So that's why, as explained in the video earlier on, emulsifying agents usually has two parts in their structure: the water-loving part and the oil-loving part. So this image will explain a bit on the activity of the emulsifying agent. So in oil in water emulsion, the water-loving part will face to the water, whilst in the water in oil droplets or water in oil emulsion, the water-loving phase will move to the internal, or to face the water droplets in the internal phase. Okay.